Here's a game so simple it sounds pointless. Mark 3 corners of a triangle. Put a dot anywhere you like. Now roll a die, pick one of the 3 corners at random, and move your dot halfway toward it. Make a mark there. Then roll again and again, jumping halfway to a randomly chosen corner every time. Pure chance, thousands of times over. You would expect a shapeless smear. Instead, out of that randomness, a precise, intricate fractal appears, the Sierpinski triangle. Order, conjured from nothing but dice. Let's be exact about the rules because they really are this simple. 3 points, the corners. 1 moving dot. At every step, choose a corner completely at random, each equally likely, and place the new dot exactly at the midpoint between where you are and the corner you chose. That is the entire algorithm. Halfway to a random corner, mark it, repeat. It is called the chaos game, and there is no plan hidden inside it, no target, nothing guiding the dots. Every single move is a coin flip, or rather, a die roll. Watch the first few dots land. They scatter around inside the triangle, hopping from one region to another, looking utterly random because they are. There is no pattern you could point to after 10 dots or after 50. If you saw only this, you would swear the whole triangle was about to fill in evenly, like static on a screen. Just a cloud of chaotic points with no rhyme or reason. Keep that expectation in mind. Now let it run. 1,000 dots. 10,000. 100,000. And the triangle does not fill in. Instead, gaps open up. A triangular hole appears in the middle, untouched, where no dot ever lands. Inside each of the 3 remaining pieces, another hole opens. And inside those, more holes, the same shape repeating at every scale, smaller and smaller forever. The random dots have traced out the Sierpinski triangle in perfect self-similar detail. Chance drew a structure of infinite precision. So why the holes? The secret is that halfway rule. To land in the central triangle, your very last jump would have had to start from a spot that simply does not exist on the figure. The midpoint rule makes certain regions unreachable, no matter what sequence of corners you roll. Every dot is forced into one of 3 shrunken copies of the whole triangle, and that self-similarity, 3 copies, each a half-size version of the total, is exactly what a fractal is. The randomness fills in the shape, but the rule carves out the structure. And here's where it becomes almost magical. Change the rule. Instead of 3 corners and a half step, use 4 special recipes for nudging the dot, each chosen with its own probability, some rotating it, some squashing it. Run the same random game, and this time the dots assemble themselves into a fern. A delicate, curling, botanically convincing fern, leaves and stem and all, built entirely from random points obeying 4 simple instructions. It is called the Barnsley fern, and it hints at something deep, that the lush complexity of living things may hide astonishingly short rules underneath. A handful of dots, a roll of the dice, and a rule you could teach a child, together producing structures of endless, perfect detail. That is the strange gift of fractals. Randomness and simplicity, combining into complexity that looks alive. This has been actually rendered. If this one amazed you, you know which button to press.